Let's take a look at the exercise 11-3. This one is about processing an array of items in the shopping cart class. I'll go to the lab environment, and let me just minimize the other projects. Go ahead and open up this one, 11-3. Okay, first thing we have to do in the shopping cart class, code the display total method, use a standard for loop to iterate through the item of arrays. Use a standard for loop, okay. Adding up the total price, okay. So if we want to add up a total price, then I want to declare a variable ahead of time to store that information. Let me just remind myself. Okay, there isn't a field for it, so go ahead and have double price. By default, it's going to be equal to 0. Then we have a for loop. For, let's create our loop counter. Int I. So as long as int I is less than our array length, our items array dot length. We'll continue looping, and after each loop, what do we do? I plus plus, increment our counter. Why is it complaining? Because I need to initialize the variable. Okay, yeah. One thing about for loops, you actually do need to assign it a value, the loop counter. Okay, set it to 0. Then what do we want to do? We're going to loop through, and with each loop, price is going to equal, we could do it like this. Price is going to equal price plus items I, whatever the ith item is, whatever item is an indice, I get its price dot get price. Okay, and then semicolon. Oh, okay, it's going to complain here because it might not have been initialized yet. If you're going to do any kind of math with it, you do need to make sure you give it a value. Okay, price is going to equal 0. So a shorthand way of doing this, though, is saying price equals plus equals. So same thing here. Price is going to equal the previous value of price plus the item and I get the price of it. Okay, so I assume that we're going to want to print this at some point. And if not, this will at least be a good opportunity to make sure that our loop is working appropriately. So let's see if we get any reasonable numbers here. Okay, 61. Yeah, that looks reasonable. Okay, it's combination of 1 shirt plus 1 pair of pants. Okay, let me take a look back at the instructions. Step 3. If the current item is out of stock, call the isOutOfStock method to skip the next loop iteration. Okay. If item I, let me actually take a look at this IOStock method. Check IOStock. Okay, so I should be able to just call this method using the dot operator, like I would setID or any other one. Okay, so it's going to be item I dot, oh, items. That's why it's complaining. Items dot is backordered. Is backordered. What do we print? Skip to the next loop iteration. Okay, how do we skip to the next iteration? Continue, we'll do that. If it's not out of stock, add the item price to the total variable that you declared and initialized before the for loop. Okay, well, I wanted us to call it total. I call it price. There should be no difference there. And then go ahead and print it out. Wristband is yeah, just to show you that, just so because it's the same price. I mean, just to identify that it is out of stock, I'll print a warning message, which should be item. Well, it is printing a warning message. Okay, so actually, let me think of a better way to differentiate that. Okay, let's say that's not out of stock. Then there should be no continue. Let's say there are. No, actually, no. I will do a print statement just to show you what has and hasn't been done. So let's see. So we want our print statement. It'll only. So you know why nothing is just complaining right here, because we have our print statement after the continue. Yeah, which means unreachable code. Because as soon as you hit the continue, it's going to loop back to the beginning. So if you want to print any information saying that the continue statement has been reached, yeah, just to show you that it actually is working, go ahead and run this. There we go. We're continuing because both the wristband and the pants are in back order. So it doesn't get factored into the total price. And the total price that we're printing out is just reflecting 25.6, the cost of a shirt. All right. So that's working. Let's get back to the presentation. Nesting loops. So just like you can have if statements nested within if statements, you can have loops nested within loops. Why would you end up doing this? Well, the most useful case to do this would be, say, to process a multi-dimensional array, or if you have a large amount of data that you want to work with. And this is actually where, when I had mentioned variables for counters I, j, and k, when you have a for loop inside of a for loop inside of a for loop, I is often the top counter, j would be the nested counter inside, k would be the nested counter inside of that. Let's take a look actually at an example that'll better illustrate what I'm talking about. Okay, in this case they're calling the counter rows and columns. So what is going on here? Example where we're printing a table of 4 rows and 10 columns using the at character. Okay. First loop right here, int row equals 0 as long as the row is less than the height, row plus plus. The for loop, so nothing is actually printed yet, so then we have our inner for loop. We'll create a column variable as long as the column is less than the width. Then we do column print, column plus plus. Then we have our print statement. It's just printing a single at character. So remember, an actual key difference here between methods print and print line. What print is going to do is it's going to it'll print your text and then not add on a new line at the end. Print line, on the other hand, does add on an extra line at the end. So if you just have a print statement, it's a way to gradually build up your output character by character in this case, or just output by output without that line separation. Anyways, let's take a look what's happening. We're printing this one character how many times? It depends on however many, what the width we want it to be in. Okay, so the for loop executes once. Okay, the top for loop executes once. We know that we're at the first column right here. And then what do we do within this first column? We're going to print the at character how many times? Well, after the first run of the inside loop, we have 1 at character. Second loop, we have 2. Third loop, we have 3. Then each loop of the inner for loop, we print an additional character. Okay, we get to the end. What do? Well, we increment the row. We move down here from row 0 to row 1. And then we repeat what we did before printing the at characters the same number of times. And then as you keep looping, you just repeat that for all of the columns that you want. Column 2, column 3. That's what's going on here. A nested while loop. In this example, let's see, we're trying to guess the name. The outside while loop is guessing to see, it'll continue looping so long as your guess is not equal to your name, okay? And what does the inside loop do? It's going to it's going to perform its actions so long as, let's see, guess.length is less than name.length, okay? So where are these values actually coming from? Guess.length, okay, so for guess, oh, it's gradually building up your, guess is going to start as a empty string, and then you're gradually adding characters onto it, and it's randomly choosing what character to add onto that string. Okay, so it'll add characters onto that string until the length is going to be equal to, so let's see, where is guess.length coming from? Name.length. Okay, so we actually do know the length of the name. So as soon as we have enough characters to meet that, then that inner loop, once we've assembled our string that we want to take a look at, match up with, then we, let's see, loop back to the beginning when you have that information and check to see, hey, is our guess correct? Does our guess match the actual name? If it doesn't, well, we're going to run this loop again, right? If not matching, then run the loop again. What do? Well, then we clear guessed. Clear guess. Guess is going to be a blank string, an empty string again. And then we just loop again, and we know that we need, say, for example, 1, 2, 3, we need 5 characters. It's going to randomly print out characters. Hey, does this match? Well, let's take a look. Then eventually, after randomly guessing, maybe it comes up with enough, like over time, there should be enough permutations that it eventually stumbles onto the right answer. But it's going to take a lot of attempts. So it looks like we're keeping track of those attempts right here. Right, that's stored as a variable that we declared before the loop executed. So then once we have our name, once our guess matches what the actual name is, no more loops occur. We go down to the lines of code following our loop after the closing curly brace. In this case, it would be 12. What are we doing in 12? We're printing the name, and we're saying it was found after however many attempts. A lot of attempts. When it comes to processing a 2-dimensional array for sales, this is what I was mentioning before with when you have a loop inside of a loop, I, J, K for your counter, I, J. So our first loop here, the first for loop, is going to be for inspecting, let's see, is it the quarter or is it the year? Sales.length. Well, if I had to guess, quarter would be 4, so I'm assuming this would be quarter. And we're taking a look at 3 different years. So let me actually compare this now to what we have up here. So sales I would be for the first one, so that would be for, wait a sec. Yeah, see this nesting loops like this, it can get confusing. When you're building it up, when you're writing it yourself, it may be a little bit easier. But then if you have a stranger come along and try to figure out what it does, or you step back after a while, it may take a little bit of time to figure out what's going on. But yeah, I am pretty sure that one loop is inspecting the. I think the outer for loop here is inspecting the year, and what's the behavior we want to do within each year. Let's evaluate each quarter. pretty sure that is what's going on here. And yes, that's exactly what's happening. Here are the results. We have, at a high level, here's our first year, here's our second year, here's our third year. Okay, but what do we do within the loop for each individual year? Let's loop through the information that we have for quarters. Quiz time. What enables you to check and recheck a decision to execute and re-execute a block of code? Check and recheck a decision. So the key word here I'm thinking is actually decision. Reason why, because that could be based on, say, a Boolean expression. Another indicator, though, is that this is a lesson on loops. So loops would be a very logical answer here. To loop through and re-execute a block of code, or in other words, to loop through code. Which of the following loops always executes at least once? No. While loop. If the Boolean expression in the while loop evaluates to false at the very beginning, you're going to get no loops out of that. So that can be 0. It doesn't matter if you nest it. If the Booleans evaluate to false, you're not going to get any loops. The do while loop, that's the do while does it at least once. And a good way to remember if that's the case is because you have do followed by, hey, here's the logic, here's the commands that we want to do, and then you check the condition afterwards. So you see the logic first. That's because, well, the logic's going to execute first. It's done once, at least. And then you check after the fact. The for loop is going to execute at least once. No, because again, it has a, even if it doesn't matter if it's the enhanced for loop or the standard for loop, you're still going to have some sort of, well, if it's a standard for loop, you could have your Boolean expression evaluate to false. If it's the enhanced for loop and you have an empty array, you're going to iterate 0 times. So that couldn't be correct. And let's finish up by talking about the ArrayList class. I hinted at this before. Arrays are similar yet different to ArrayLists. Arrays are not the only way to store a list of relevant data. ArrayList is one of several list management classes that Java provides to you. And it also has methods that are associated with it, like you have the ability to add an object to array, add an object to the array list, get a particular object from the array list, remove it, find an object at a particular instance. One big advantage with an array list compared to an array. When you declare an array, you are locked into your size. When you declare an array list, you can expand it, you can shrink it. The space changes dynamically based on however many elements you want to put inside of that array list. So if you know ahead of time how much you want to store, array may be a good option. If you don't know how many you want to store ahead of time, array list is worth considering. And here are just some examples of you. I should also actually mention first, though, that array lists, they only work with objects, not primitive. So you wouldn't, okay, there are workarounds, but you normally wouldn't have an array list of ints. You wouldn't normally have an array list of doubles. These are primitive. So instead, you'd want to consider using an array to store an array of primitives, or there's a workaround, which you'll get to see later. And just some examples of calling a few methods on a shirts array list. Yeah, so this is a shirts array list. This is a names array list. This is a ages array list. I'll show you how to go about creating them later. What we're doing, and they're all instance methods, so you need to have an instance created. So you have your instance, your reference variable, followed by the dot operator, and then add. and you're adding in an object here, an object being shirt4 that you create an instance of. You can also choose to remove an object. If it's a string array, then you're specifying what that string is that you want to get rid of, the actual string literal. For an array list of ages, you can't add a 5 because a 5 is an int, is a primitive. Instead, you have to use, remember, the wrapper class that we had talked about. So integer 5, it provides a wrapper class. It creates an object containing the only thing that it contains is inside that primitive. But because it's wrapped around, because you have that wrapper that produces it as an object, you are welcome to do it. Have your array list like this. Benefits of the array list, again, array lists allow you to grow and shrink. They grow and shrink in size depending on whatever elements you add or decide to remove. You do have the option of specifying an initial capacity, but you don't have to. How do you go about declaring an array list? Array list for the object type, followed by, I don't want to go too far in depth into this because this is actually in the Programming 2 course, but these right here, this is called working with generics. But essentially what you're doing, and all you need to know for now, is you're specifying what type of data the array list is going to contain. So in this case, you're saying this is an array list of strings. We have our reference variable. This array list is going to be called states, and you have the constructor called new array list. Also worth mentioning, their array lists are coming from the java.util package, which isn't automatically available to you, so you need to write an import statement before you go about using them. But if you forget, NetBeans will remind you. How do you go about calling methods on an array list or an element? So here's a method .size, different than .length. .length would be for an array. For an array list, it's .size. And it just gives you the size of the list. It's an instance method. If you want to call a method on a specific object within the array list, you use one way to get a specific object is here. You have your reference variable .call method get. What is it going to get? It's going to get whatever object is at index 49. In this case, right, so it's an array list of strings, so we can get the length of that string. So you can think of this right here as this returns a string. So once you have a string, dot, and then whatever method or field or fields are available to you from the string class. Yeah, again, important details when you declare an array list, you need to make the import. So here's where I goof. Java.utils star to import everything, right? It's in that package. So if you want to just specifically import the array list, this is the call that you make, import java.util.arraylist. If you look right here, so we're declaring our array list of type, an array list containing shirts of the shirt. So it'll be an array list of shirt objects. Its name is going to be my list. We can go a little bit further here because we have to actually create that new array list, and that's being shown here in the next example, done on 2 lines, which can be done, with primitives. You can also take this approach with objects. I mean, just be careful that you actually you instantiate it before you do any kind of work. So if line 2 wasn't there and you go to check the names before actually allocating memory or to bring that array list into existence, you'll get an error. But thankfully, we do have line 2 here, so we've created an instance of our new array list. What's going on? Let's take a look at the code. We're adding names. And they're added at, okay, let's say here you have your array list. And it's going to have a, here's an element, here's an element, here's an element, here's an element. The first one is at index 0, index 1, index 2, index 3. When you add an element, by default, it is added, I shouldn't say by default. So the add method is overloaded. You're able to specify a location where you want to add in the next element, but if you don't provide a location, it'll be added right onto the end. So then this would end up being, well actually, but right now there are 0 elements, so this ends up being the first element, this ends up being the second, this ends up being the third, this being the fourth. Okay, and so then we get to line 8. What are we going to do? Add Prashant in at element 2. So we actually just squeeze Prashant in right here, and then we have element, what was element 2 becomes 3, what was 3 becomes 4. We grow the array list that way. When it comes to removing elements, again, instance variable for name is going to be the names of our, that's a reference variable for our array list, called the instance method remove. We're removing whatever is at index 0 or element 0. Okay. What if we want, that's for removing the first element. What do we do if we want to remove the last one? Well, you can get the size, but then you got to subtract 1. Why? Because the size is actually going to be a count of all the elements. But since we're actually counting with 0, the final index is going to be 1 less than the size. So if you try to remove something that's equal to the size, you are out of bounds. So you need to subtract 1 just so you get the last element. And so the method is also overloaded in that you can specify a literal, or a reference to the object that you want to get rid of. So yeah, it's overloaded in the following ways. Here, you specify an index. Well, this is also specifying an index, but you're doing a little work on it too, mathematically, to subtract 1. Or you give it the object reference, or the in this case, a string literal. All right, and that'll actually take us to exercise 11-4, working with an array list. Try it yourself, but if you don't get it, let's walk through it. I'll go to the environment, close what we were doing before. I'll go ahead and open that project. Exercise 4, there's our NetBeans project. Shopping cart, okay. Declare, instantiate, and initialize an array list of strings. Okay. It's going to contain 3 elements. We don't need to specify an initial size. I'll let that grow dynamically, but it is array list. To specify that, it's an array list of strings. We'll type this. Put string in between the less than, greater than for the generics. What are we going to call it? I'll just call it list equals new array list. Okay, and NetBeans is going to complain because we need to make the correct import. Ta-da, there it is. Error complaints. Okay, next step. Okay, so it wants us to print and test it. So one way to go about doing that is I could do the enhanced for loop because remember, enhanced for loop works on both arrays and array lists. So for each string s inside of our list, what do? Print that string. But I'll run it, but it's not going to print anything because we didn't add anything to the list. How do we go about adding things? List dot add. We can add strings. What can we add here? What would be good? Add in Duke. List dot add. And Mrs. Duke. List dot add. How about Mr. Duke? That's his father. Okay, now I'll go ahead and print that, see what we get. And the reason why I'm putting a for loop down here to print is, at this point, the code's still being read line by line, but here nothing is being printed by the time we get to line 12 because we've added nothing to the array list. Nothing's going to print until we get to line 20, here at line 21 after we've added this stuff here. So we add it, we add it, we add it. Now let's go print. There we go. Duke, Mrs. Duke, Mr. Duke. Let's check the instructions again. Add a new element in the middle. Okay. I'll do this at element 1. 1, comma, evil Duke. So now we've injected evil Duke into the family. And we've printed it so we can see the effects here. Okay. Now let's check to see if a specific element exists. Let's check to see if Mr. Duke exists. So if, what do we call it? We call it list. List dot contains, okay, and then we'll provide to it a string literal, but it's really looking for an object reference here. Mr. Duke. Let's see if it contains it. If it does, I'm going to print out found, if we found Mr. Duke. Okay, we found him. What do we do if we want to remove him? What methods are available to us? Let's see. List dot get. No, let's see. I don't. I was thinking I could get the index of a particular object, but get isn't overloaded where I can put in an object reference or a string literal. But maybe I don't need to do that. Maybe I can just do a more direct approach of remove. Okay, yeah, so I was thinking I'd have to specify an index to remove it, but it turns out it's overloaded so that I can just specify the object instead. So let's do that. Mr. Duke. And then I'll go ahead and print it one more time just so you can see the effects. Okay, in our final list here, Duke, evil Duke, Mrs. Duke. Mr. Duke, the final element, has been removed. All right, and that is the end of that exercise. Let's get back to the presentation, and that's actually the end of the lesson. So by now, you should have learned how to create a java.time.local datetime object to show the current date and time. Local datetime. Parse the args array of the main method, nest a while loop, develop and nest a for loop, and code and nest a do while loop. And finally, use an array list to store and manipulate data. Store and manipulate objects. So there are a couple practices associated with this lesson. Go ahead and give them a try. If you get stuck, I'll walk you through them in the next videos.